So here we have to state whether the average velocity is positive, negative or 0 for the time interval 1 to 2, then 2 to 3 and finally 3 to 4. And I'm sure after watching this video we'll be able to give this answer comfortably. Welcome to STEM Professionals. In this video we'll discuss the topic, the graphical interpretation of average velocity. So let's start with the video. Now in the last video we discussed about the average speed and average velocity. Now it's often useful to visualize a particle motion by sketching its position as a function of time. And for that we'll discuss the topic graphical interpretation of average velocity. Now before discussing this topic you should know one concept, that is the slope of a line. So we'll discuss the slope of a line first and then we'll get back to this topic. So this is the line that represents the equation y is equals to x, and we need to find the slope of this line. Now for that let us consider any 2 points on this line. So the 2 points are this one, let this point be A and let this point be B, and the coordinate of these 2 points is, this is 1, 1 and here this is 2, 2. Now this would represent, let me show here, this would be delta y, the change in y coordinate, this is the y axis and this is the x axis, and this would represent the change in the x coordinate, that is delta x, this thing. Now slope is defined as rise over run. So rise is delta y and here this is delta x. So slope is defined as the ratio of delta y over delta x. So change in y coordinate. So this is x1 y1 and here this is x2 y2. So change in y coordinate would be y2 minus y1, that is 2 minus 1, divided by change in x coordinate. So this is also 2 minus 1, so 2 minus 1. So slope would be 1. Now there is another way to find this slope. So suppose that this angle is theta. So this angle would also be theta, corresponding angles. Now if you find the tangent of this angle, that is tangent theta, so that would be equals to delta y over delta x, which is nothing but the slope. So if you find the tangent of this angle theta, you will easily get the slope. Now be careful that this angle theta is measured in anti-clockwise direction from the x-axis. This angle is measured in the anti-clockwise direction from the x-axis. Now if this angle theta increases, suppose now the line is something like that, so this angle theta increases. So if theta increases, then tangent theta would increase, and if tangent theta increases, that means the slope will increase. Now let us consider one more figure. Now this is the line that represents the equation y is equals to 5 minus x, and we need to find the slope of this line. Now again we can consider 2 points, let this point be 1 and let this be the second point. Now if you write the coordinate of this point, this would be 5, 0 and this would be 0, 5. So this is x1 y1 and this is x2 y2. Now slope, we know it is delta y over delta x, so we can write that slope, okay, let me write here, slope would be equals to delta y over delta x. So this would be delta y, the change in y coordinate, and this would be delta x, the change in x coordinate. So delta y would be 5 minus 0. So this would be 5 divided by delta x would be 0 minus 5. So that would be minus 5. This would be equals to minus 1. So here slope comes out to be as negative 1. Slope is negative here, and here the slope is positive. So here we noticed one thing, that in this case the theta was greater than 90 degrees. This was the theta which is greater than 90 degree, and here in this case theta was less than 90 degree. So whenever theta is between 0 to 90 degree, the slope would be positive, and whenever the theta is between 90 degrees to 180 degrees, the slope would be negative. And what about when theta is 0? So when theta is 0, slope would be 0. Slope would be 0 when theta is 0. So I hope you are done with the slope. Now let's move to our main topic, that is graphical interpretation of average velocity. Now let's take an example here. Now a particle moves back and forth along the x-axis, and this table shows the position of the particle at different time. So say that at time t equals to 0 second, the position of the particle is x equals to 1 meter. Now when the time becomes 2, the position of the particle is 4 meter, and so on. Now that's not a good way to show the particle's motion with respect to time. So let's plot the same information on the xt graph, that is the position versus time graph. So let's plot these points on the xt graph. So we have plotted the xt graph. This side, this is the position x, and here this axis is time. Now these are the coordinates. Time, when time is 0, position is 1, so this is 0 comma 1. Similarly 1 3, so 1 comma 3, and so on. Now let's join these points with a smooth curve like this. Now it makes easier to visualize a particle's motion. Now we can do one thing, we can divide the particle motion in two parts like this. And in the first part we see that the particle moves in a positive direction, and in the second part the particle moves in the negative direction, which you can see from this table also. Like when time increases, when t is increases from 0 to 1 second, the distance is increased from 1 to 3. When time is increased from 1 to 2 seconds, the distance is also increased. But now when time increases from 2 to 3 seconds, the distance is decreased. It becomes from 4 to 2 meter. Therefore, for this part, from time t equals to 0 seconds to 2 seconds, the particle is moving in a positive direction, and then it moves in a negative direction. Now with the help of xt graph, we can find the average velocity. Now to see how, suppose you'd like to know the average velocity for the particle from the time interval t equals to 0 to t equals to 3. So for this time interval, you need to find the average velocity. Now the average velocity that we studied earlier, it was, let me write the formula. This was xf, the final position, minus the initial position divided by tf minus ti. This is what we studied earlier. Now final position here, it is for time equals to 3 seconds, it is 2. So we can write 2 minus xi. Xi is 1, so we can write here 1 divided by tf minus ti. So tf is 3, and initial time we have 0. So that would be equals to 1 over 3. This thing we have calculated from this table. Now let's calculate the average velocity by using this this graph, this xt graph. So for that, the procedure is that you need to join the points. Let me show it on the figure first. Now we have to take time t equals to 0 to 3. So here this is t equals to 0. So let this point be A. And here this is t equals to 3. So let this point be B. Now I'll join these two points by using a straight line. So let's join the points now. So we have joined it. Now this would be delta t and this would be delta x here. Let me write it here. This is delta x and this would be delta t. Now from this graph we can write that the ratio delta x over delta t is nothing but slope that we studied earlier in this video, and this delta x over delta t is nothing but the average velocity. So here's the thumb rule, that the slope of a line connecting two points on an x versus t plot is equals to the average velocity during that time interval. So the procedure is very simple to find the average velocity by using this graph that I've discussed just right now. Now one more thing, when the slope is positive, in this case the slope is positive. Why? Because this theta is positive. This theta ranges between 0 degree to this 90 degree. So if theta ranges between this, the slope would be positive, and if slope is positive, the average velocity would be positive, which we have obtained this. This is positive 1 over 3. So that's true. Now we'll be finding the average velocity of the particle from time interval t equals to 2 seconds to t equals to 3 seconds. So at time t equals to 2, this is the position. So let this point be A. And at time t equals to 3, this is the position. So let this be point B, B. Now we're going to follow the same procedure. That is, we're going to join these 2 points with a straight line like this. And this would be delta x, delta t, and this would be delta x. This is the x-axis, that is the position, and this is the time axis. Now the first thing that we notice here is the slope of this line is negative slope, because if you see this angle theta, if you extend this line like this angle theta is greater than 90 degree. And when theta is greater than 90 degree, the slope would be negative, or other way around we can see that delta x, that is xf minus xi, this was the initial position xi and this is the final position xf. So this value xf minus xi, this value is less than 0. So here also that slope is delta x over delta t, and since this delta x is less than 0, so the slope would be negative. Or other way around, from this also we can see that the theta is greater than 90 degree, that means slope is negative. Now if slope is negative, that means the average velocity would be negative. So the average velocity, this will be negative, and its value would be delta x over delta t. Now delta x would be x coordinate, here we have 2 and here we have 4. So 2 minus 4 divide by, this is 3 minus 2. Delta t is 3 minus 2. So that would be minus 2. So this negative is why? Because this slope is negative. So that is why we obtained this average velocity to be minus 2. Now we'll get back to the question that I discussed in the starting of the video. And this was the question. In this question we have to state whether the average velocity is positive, negative or 0 for the time interval between the points 1 and 2, then 2 and 3, and finally 3 and 4. So we'll be solving the A part first. So in the A part we have to consider the point 1 and 2. So this is point 1 and this is point 2. So first we're going to draw a straight line between the point 1 and 2 like this. So the slope of this line will be the average velocity for the particle in the time interval 1 to 2. So the average velocity, this would be equals to slope of line 1 to 2. Now here we see that the angle theta would be in the range 0 to 90 degree. Therefore, the average velocity would be positive because this slope is positive. So for the A part, we can write that average velocity is positive because this slope is positive. Now let's discuss the B case. So in this case, let's join these 2 points like this. Now here we see that the slope is 0 because the theta is 0, or the change in the position in the, is 0. So the average velocity in this case, it would be 0 since the slope is 0. Now final case is left, that is the C part. Now I left this question for you, and you have to solve this part on your own, and you have to write this answer in the comment box below. So this is all with this video, and in the next video we'll discuss the instantaneous velocity. So we'll meet in the next video. Goodbye.